Hello everyone, I'm Siddharthan. In today's video, we will be building a multiple disease prediction system using machine learning, and we will be deploying the system as a web app using Streamlit in Python. So this is how the end result of our web app will look like. So we have a navigation bar or a sidebar here from which we can choose the disease for which we want to make the prediction. So first we have this diabetes prediction, and you can see various input fields here. So these are all the features based on which we have trained our model. Okay, so we have to give these give some values for this input field in order to predict whether a person is diabetic or not. And the second disease for which we are going to predict is the art disease prediction, and here as we can see the features will change. And finally we have this Parkinson's predictions. So this is the web app that we will be building for multiple diseases. Okay, so you can use this in order to add much more diseases than this. So we have also worked on the breast cancer prediction in our YouTube channel, so you can add this to this as well. Okay, so this is how all these things work, and I'll show you how you can build a similar web app from scratch in Python. Okay, so this is the agenda for today's video. And so we will be building this system in Spider. Okay, so I have my Spider here. So if you don't have Spider, you probably need to install Anaconda, and you have to install like Spider from here, and the required libraries for this particular thing. And I have already made few videos on getting started with Streamlit, how you can install the libraries that you need and so on. So I'll give the link for this specific playlist, and these are all the videos required, or you can think about these videos as prerequisite for this particular video, but you don't have to watch all these videos. So if you remember, we have already worked on use cases like this diabetes prediction, and art disease prediction and Parkinson's predictions, where we have given some data set, and we have trained a machine learning model, and we have made some prediction. And the first video is about how to install this Anaconda and how to install the Streamlit library and so on. So I've explained this, so you can watch this if you have no idea on how to install the Streamlit and how all these things works and so on. And in the second video, I have deployed a simple diabetes prediction app. Okay, so you can watch that as well. Okay, so if you have watched all these things, you can just continue with this one. Okay, so the first thing that we need to do is we have to save the models that we have built in these videos. Okay, so I have done this here, so you can see this one here. So we have this multiple disease prediction system. So this one is for the diabetes video that we have worked on. So this is the same code that we have worked on here. Okay, so in this video, I hope you have already watched this one. So it is the same code, and then we have this for the art disease prediction and the Parkinson's prediction as well. Okay, so here you can see this diabetes.csv. I'll just show you how you can get this model file. So first, just upload the dataset file. So I'll also be sharing this model file as well as the dataset file, so you can train your own model and you can save it. So I have a folder in my desktop called as dataset. So here I have this three dataset files. So first, let's upload this diabetes file, as this is the collab file for this collab notebook for diabetes prediction. Okay, so this CSV file is uploaded, and so in the end you can see, so we have, like in that diabetes prediction video, we have done until this part where we give some input data and it will predict whether a person is having diabetes or not. Okay, and this is the additional code that I have written. So this is to save the model. Okay, so this is not necessary, so this is just loading the saved model and so on. So the two most important things are like this import pickle, and we are like saving this model. So diabetes model.sav, so this is the important one. So we have already kind of saved the model. Sorry, so we have already uploaded the dataset file here as diabetes.csv. So I'm going to run all these cells. So what happens is, once my model is trained and once my model is evaluated here, so you can see the accuracy score that we are getting. So here we are saving the model. So I'm importing the pickle. So this pickle library is used to save your models to a specific file. So I'm saving the model as a SAV file, and the name of this file is diabetes underscore model. Okay, so you have to mention, so this is the variable that I'm creating, and I'm mentioning the name of the file, and I'm saving it using this dump function. Okay, and I'm writing this as bytes. Okay, so that's what like WB represents, and here I'm reading the file as bytes. So if you open your file explorer, here you can see this diabetes model.sav. So you can go ahead and download this particular file. So this is the model file that we need in order to work on this disease prediction system. So similarly, you have to do this for this art disease prediction and Parkinson's prediction as well. Just go to the file explorer. If this is the art disease, collab file, so you just need to upload that specific dataset file that we have worked on. So here you can see this art.csv. Okay. So once you have uploaded this, once your system is connected, just go to runtime and click this run all. Okay, so I will be sharing you all these collab files as well. So these are all the features that this particular data set contains. So we have age, sex, and so on, and finally we have this target. So this target is nothing but whether a person is having heart disease or not. So if it means 1, that means the person is having heart disease. If the target is 0, that means that person doesn't have heart disease. So this is what we have represented in our web app. So if you go to this art disease prediction, so we have this age, sex, chest pain types, and so on. So that is what we have in this particular data set file. Okay, so I'll show you how we can determine what these features means and so on. But for now, understand that we just have to upload this data set file and just run all the cells, and you will get this model. So again, save this file and do this for Parkinson's as well. So in this case, you have to upload the Parkinson's data set and so on. So I'll just show you that as well. So I'm uploading the Parkinson's data, which is parkinsons.csv. As I've told you, we have worked on this in these videos. So if you want a detailed explanation of what we are exactly doing in this case, so please watch those videos. Okay. So here we have, so this parkinsons.csv is uploaded. Now I'll go to this runtime and run all the cells. And this will create the model. Okay. So as we know that we are saving the model in this case. So using this pickle, so import pickle, and I'm saving the model as Parkinson's model.save and dump model. So this model is nothing but, so we are loading our SPM. So in this case, we are using the support vector machine model, and we are loading this, training the model and evaluating it, and then we are saving this model in pickle. So these are like simple steps. So you just have to go to this individual collab files, upload the data set, and finally run all the cells so that your model file will be generated. Okay, and once these files have been generated, so you just have to go to this options and download these files. Okay, so I'll also give this model files as well if you don't want to run all these collab files and so on, but I suggest you in order to to run all the cells, so that will be better exercise. So okay, now I'll close this one. So I've already saved this model, and I have put all these things in this folder in my desktop. So this folder called as saved models will contain these files. So diabetes model.sav, rdisease model.sav, and Parkinson's model.sav. Okay. So these are all the models that we are going to use in order to make predictions in this particular web page. Okay. This Streamlit web page. Okay. Now let's try to build this UI aspects of this app. Okay. So for this, you need like 3 important libraries. So I'll go to this Chrome, and the libraries that you need are Streamlit options menu. So first is you need pickle in order to load the pickle files that we have created, or the SAV files that we have created. So just you can search as pickle pypi. So where if you go to this pypi, so you will get this command to install this specific library. Similarly, you can go to Streamlit pypi, and you can install this Streamlit library. And then the important thing is installing this Streamlit options menu. So this is like a add-on library that we have for Streamlit in order to create the sidebars. Okay, so we have seen the sidebars, right? So here we can, so we have created the sidebar. So using this Streamlit options menu library, we can create this good sidebars that we need. So that is the purpose of installing these 3 libraries. So you just need to go to this, copy the command here, and you need to come to your Anaconda navigator. So in this Anaconda navigator, so we have the swarm and we have this environment. So make sure which environment you are running. So I have this base root environment. I have created another environment called as machine learning. If you don't understand what I'm talking about in this case, so just go to that playlist, watch this first video. So in this video, I've explained what does this environment means and how to create this environment, how to install libraries and so on. So in this environment, you just have to go to this play symbol, open terminal, and paste the command that we have copied. Okay, pip install Streamlit option menu. So this will install that specific library. So you have to do this for pickle, Streamlit, and Streamlit option menu if you don't have this library already installed in your system. So apart from that, you need this NumPy library part as the basic libraries and all those things. Okay, so that is another like mandatory thing. And so I've already installed these libraries, so I'm not running this one here. So sometimes you can get a error as access denied when you run this particular commands. So in that case, what you have to do is, so yeah, you have to run your Anaconda Navigator as administrator. So if I search this Anaconda Navigator, you can see this run as administrator. So in that case only your libraries will be installed. So that is another thing that you need to remember. Okay. So the next step, as I've told you, will be installing the specific libraries that we need. So the first step is, capturing or saving this model files. And the next thing is installing the libraries that we need. The three main important libraries, which are Streamlit option menu and pickle. Okay, so Streamlit is for deploying this as web app. Streamlit option menu is for creating the sidebars, and pickle file is for loading the models. Okay, so I'll close this one as of now, and I'll close this file. Okay, so let this be here. And the next thing, yes, we can go to our spider. Okay, so here, so this is where we will be creating the UI for our web app. So this will be completely done in Python, and for this only we need Streamlit library. Okay, so the next thing is, I'll go to my desktop, I'll create a folder, and I'll name this as multiple disease prediction system. Okay, so multiple disease prediction system. So this is where I'm going to save all the files that I'm working on. Okay. So now I'll just close this Streamlit one. So this web app has been created already. So I'll close this one. So let's build this from scratch. And as I've told you, if you want, you can watch this playlist in order to get a better understanding of all the things that we are doing here. So I'll close this one as well. Let's have these three collab files as of now. Okay, now I'll go to the spider. So I have an untitled file. So this is just an empty file that we have. And if you want to create a new file, just go to this file and create new file. Okay, sorry. So you have to go to this new file. So a new file will be created. And now just press Ctrl plus S in order to save this file. And I'm going to save this file in the desktop, where I have created a folder called as multiple disease prediction system. And I'll rename this file to multiple disease pred. Okay, right, where it stands for prediction. Okay, so this is where we'll be doing all the coding aspect of things. So in this, this is multiple disk spread.py file. Okay, so the first thing is importing the libraries that we have just installed. The first is I'm importing my pickle library, which is used to load the saved models. And then we have this import Streamlit, and I'm going to import Streamlit in a short form as ST. Okay, so where ST stands for Streamlit. And finally, from Streamlit option menu. So this is the third library that we have installed. I've told you, right, the add-on library that we need in order to create the sidebars. So from Streamlit, import option menu. So this option menu is the function that will help us to create those sidebars. Okay, so we have done this. Now we have to load the models, as I've told you. So we have downloaded the models from this file explorer, right? So we have like downloaded those three models. So first is our diabetes model, then the art disease model, and finally the Parkinson's disease model, right? So we have saved this model, and I have kind of copied those model files to this folder called as saved models. Okay, as you can see, so a diabetes model is for predicting diabetes, art disease for art disease prediction, and finally we have the Parkinson's model as well. So I'll just cut this particular folder, and I'll just paste it in this multiple disease prediction system folder itself. So here I have this Python file, which is multiple disease spread.py, where we will be writing our Python codes, and we have this second folder called as saved models, where all my models are saved. Now we have to load all these models in our Python file. Okay, so using pickle. So let's see how we can do that. So this is loading the saved models. So we have to load all those three models. First, let's load our diabetes model. So I'm naming this model as diabetes model. So you can just name this anything. So this is just a variable that we are creating. And so we have imported this pickle, right? So we have to say pickle.load. So previously, in order to save the models, we have used pickle.dump. Okay, so dump will save all those parameters of the model into a file called as Parkinson's model or diabetes model or whatever the model that we are saying. In order to load that saved model, we have to use this load function from pickle library. So it's pickle.load, and we have to say open. Okay, and within this open, we have to mention the path of the model file. So this is for diabetes model, right? So I'm going to this folder. Okay, so saved model. So I have this multiple disease prediction system folder. In that I have the saved models, right? So go here and copy the path. So this is the path of this. So go to file explorer, copy the path and just paste it in this open. So this should be pasted within quotes. So you can use either single quotes or double quotes. So it's up to you. Okay. So I'll use single quotes here and I'll paste this path of the folder, which is my saved models folder, where all the saved models files are located. Here the main thing that you have to note is, so here we have like backward slashes, right? So you have to replace all those backward slashes with forward slashes. So then only spider kinds of understand that it is the path of the file that we are mentioning. So we know that we have created a folder in this desktop. So it is in desktop multiple disease prediction system and in saved models folder, right? So after the saved models, you have to mention the name of the file that we are loading. So this one is for diabetes model. So we have to mention the name of the diabetes model file. So I go to the saved model, I'll click this and I'll go to rename and I'll copy this entire thing, which is diabetes underscore model dot save. So you have to like do these steps very carefully. So here now you can see, so here we are creating a variable called as diabetes model, and this is where we are loading the saved model. So pickle.load open, and I'm mentioning the path of the file where the diabetes model has been saved. So diabetes underscore model dot sav, which is my saved file. Now I'll just copy this entire thing and I'll just paste it here. Okay. So the first line is for loading the diabetes model, and now let's load our heart disease model. So let me put this. So instead of diabetes, let me write this as heart disease model. Okay, so heart disease model, and here you have to change the name of the file. So all these are in the same location, so we know that. So we just have to change the location of the file. So this is heart disease model. Just click it, go to rename. Okay, so just go to this rename and copy all those things, heart disease model dot sav, and here we have this diabetes model dot sav, right? So just replace it. So this one is for loading our art disease model. So similarly, we have to do this for Parkinson's model as well. So I'll copy this one and I'll paste it here, and I'll replace this diabetes with Parkinson's. So these are the three diseases that we are considering as of now. So if you want, you can also refer my breast cancer prediction video, and you can also include, along with these three diseases, you can build a breast cancer disease prediction model as well. So this is just, a demo or something. So it's not that you have to use only these diseases. So you can use this in order to build prediction system for other diseases as well. So this is just like a template that you can use for a later time. Okay, just a sec. Okay, so now we have to rename this diabetes model.sav to Parkinson's model.sav. So I'll go to rename, copy the name of the file, and I'll replace this here. So here we are loading all the three models. First, I'm loading my diabetes model, mentioning the path of the file, and the main thing is we have to replace the backward slash with forward slash, and then mention the name of the file, which is diabetes model. The second one is our disease model, and finally we have Parkinson's model. Okay, so the next thing that we have to do is create the sidebars that we have seen before. Okay, so this is where we will be using this Streamlit option menu. Okay, so here as you can see, we have imported this option menu right from this Streamlit option menu module. So let's see how we can use this. So this is for sidebar for navigation, where we can navigate to different diseases for which we have to make the prediction. Okay, so just save with sidebar st.sidebar. Okay, so this st is nothing but the Streamlit library that we have imported. So this Streamlit library has a specific module or a function called a sidebar, where we can create this sidebar or navigation bar. In order to have better sidebars, we are including this add-on library, which is Streamlit option menu. So in this, we can create a variable called as selected or select. So whichever you want. So again, this is a variable name. So here I'm going to call this function option menu. Okay, so option menu, and here we have to name this as, let's say, multiple disease prediction system. So you can just put multiple disease prediction system using ML or whatever you want. So it is completely up to you. And I'll just put a comma here, and now we have to create a list. So this list is for what are all the different pages that we want. So as we know, this is multiple web app, multiple page web app, as we have seen before, where in each page you can predict for different diseases, right? So here you have to mention the name of the different pages for which we are creating. Okay, so that is the purpose of this. And so I'll create a list with this square brackets here, and the first element will be uh, diabetes prediction. Okay, and next thing will be heart disease prediction. So these are just titles for our pages. Heart disease prediction. And so after this name you have to just mention a comma here, or else you will get an error. And finally we have this Parkinson's prediction. Okay, and let me put this icons predictions. Okay, so let's go to this icons later. Let me include another parameter, which is a default index. So I'll explain you what this default index means in a second. Is equal to 0. Now let's uh, okay, so there is an error. Expression cannot assignment perhaps. Okay, so let's worry about it later. So selected is equal to option menu multiple disease systems, and yeah, so default index is equal to 0. Let's see whether this one is running. So for this, I'll go to this multiple disease prediction folder. So here I'll just create a text file. So this is just for command. So I'll name this as Streamlit run command. So this is how you can run the file that we have created just now. So that is the purpose for it. And so the command that we have to use is Streamlit run, and here you have to mention, so there should be double quotes, and within this double quotes you have to mention the path where this Python file is situated. So it's multiple disease prediction system, and mention that path. And here you should not replace the backward slash with forward slash. Okay, so here it should be the backward slash. And now copy the name of the Python file that we have created. So I'll copy this one and I'll put it in this notepad file, and use the closing double quotes. Okay, so we have Streamlit run and the path of the Python file that we have created. So we have to use this command in order to run this Streamlit web app. So now you have to go to your Anaconda, and this is the environment that I'm working on, which is like the machine learning environment. So if you're working on your base environment, you can just go to this and you will see this play symbol near this base root. So I give this here, you will find an option called as open terminal, the same place where we have used the pip install command to install libraries. So here we have to paste the command that we have copied here. Okay, so which is Streamlit run and the path of the Python file. So let's paste it. This will open a page in Chrome or your default browser. Okay, so this is the local host in which we are running this. So diabetes model, so there is some error in this case. Okay, so let me check this one. So multiple disease prediction system. Okay, diabetes prediction. Expression cannot contain int. Okay, so selected is equal to option menu multiple disease prediction system diabetes prediction. Okay, so here we have used full stop, so that is the reason that we are getting this error. So I'll save this one, and this file has been changed. So you can see here that the source file has been changed. So you have to refresh this page in order to give that a particular change. Character maps. Okay, so I'm just getting an error. So I'll just complete the remaining part of the few part of this code. Let's see whether it is running in that case. And now I have to say the first is diabetes prediction page. Diabetes prediction page. And if selected is equal to, we have to copy this diabetes prediction. So I'll explain you what I'm doing here. Just give me a moment. So diabetes prediction. So if this has been selected, we have to give the title of the page as, so let me put this as page title. So in the sidebar, we have to choose whether we want to go to diabetes prediction or heart disease prediction or Parkinson's prediction. Okay. So once we give that one, so it will go to the respective if condition. So we have the page title. So let me put this as st dot title, t dot title, and let's name this as diabetes prediction using ML. Okay. Now we have to do the same thing for heart disease prediction and the Parkinson's prediction as well. So let me put this as if this selected, shall open a bracket here. So if this selected is equal to heart disease prediction, so just copy this and paste it here. If the user chooses this one, in that case, the page title will be heart disease prediction using like using ML. So if you don't understand this, don't worry. I'll just explain this once I complete this one. Let's put this as heart disease predictions or heart disease prediction using ML. And finally, we can add this for Parkinson's prediction as well. So let's copy this Parkinson's prediction, paste it here. And if Parkinson's has been selected, the name of the title of the page should be Parkinson's disease predictions or Parkinson's prediction using ML. So you can give any names here. So I'll save this one, and now let's see whether the page is working or not. Okay, still I'm getting an error. So let me just check what this error is. Okay, so the reason we are getting this error is, so while saving the models, we have written this file, this diabetes model.sav file as bytes format. So that is what like this B represents. WB represents writing this file in a bytes format. But while loading this file or while reading this file, we didn't mention that it should be in the form of bytes. So that is the reason for this error. So this can be solved by including just this RB after this path. So here we are mentioning the path of the model file, right? So after mentioning that path, we have to just put a comma here and say RB, which stands for reading the file as bytes. Okay, so let's put that for all the models that we are working on. So just put RB. Okay, so here as well. So comma RB. Now this will resolve our issue. Okay, now I'll go to this page that we are working on. So just a second. Okay, so I'll go to this multiple disk spread which is running on our local host. I'll refresh this page, and now we will get our UI working. Okay, so we have created this multiple disk prediction system. So if we go to this spider, so this is what we are creating. So we are creating this with st.sidebar. So this particular line of code will create this sidebar. So you can just close this one or you can open this one. So that this is the purpose of this with st.sidebar, and selected is equal to option menu. Okay, so in this selected, we have different menus or different pages for which we are creating this, right? So first we have this diabetes prediction, and then we have this heart disease prediction and Parkinson's prediction. If you see this line, which is multiple disease prediction system, so this is what we are showing in this case. So you can see this multiple disease prediction system. You can also like put using ML if you want here. So if you just put this as using ML, and let's save this with control plus yes. And now if you go to this page and refresh this, so this will be saved here. Okay, so multiple disease prediction system using ML. So for now I'll just remove this one. Okay, so let it be multiple disease prediction system. Okay, now I'll run this one. Okay, so I didn't save this file. So once you change the file, just press Ctrl plus yes. Now you can go to this refresh. Okay, so yeah, so now this change has been involved. So I hope you remember how we are opening this local host. If you don't, I'll just show you again. So I'll just close this one, which is already running. Okay, so you have to create this line which is Streamlit run. So it's Streamlit run, and you have to mention the path in which this Python file is situated, which is multiple display.py. If you remember, I have created a folder in my desktop. So this is where my file is. So you have to mention this. So Streamlit runs the path of the Python file where we are building the Streamlit UI. So I'll copy this. So after copying, I have to go to my Anaconda navigator to this environment, and in this play symbol I have to give open terminal. So here once you paste this, so your local host will be opened in your default browser. So my default browser is Google Chrome, so it's opening there. Okay, so here you can see my multiple disease prediction system. Now, so what we have mentioned here is selected if the user select this diabetes prediction system. So if the user select this diabetes prediction, then we have to open a page where the title is diabetes prediction using ML. Okay, and next if the user select heart disease prediction, it should open the page where the title is heart disease prediction using ML, and similarly for Parkinson's prediction. Now you can go to this page and you can select this heart disease prediction, and now you can see the title change, and now we have this Parkinson's prediction using ML. So you can change the titles if you want. So that's what we are doing here. Now in each of this page, using the models that we have loaded, we have to build this system where we can get the input from the user and predict whether a person is having diabetes or heart disease or Parkinson's. So that's what we are going to do in the next step of our code. Okay, so, and I've told you, right? I'll explain you what this default index means is. So default index is equal to 0 means when you open this navigation bar, or when it opens for the first time, the page which is selected is diabetes prediction. So this is my index 0. So if I put my index default index is equal to 1, then this will be the starting page. The R disease prediction will be my starting page. So I'll go to the spider, I'll replace this to 1, and I'll press Ctrl plus S to save this file, and I come to my page and refresh this. Now you can see this is in this R disease prediction. Now you can change this to diabetes prediction or Parkinson's prediction. So in this case, if you just put this as 2, so the default starting index, so the default selected page will be Parkinson. So I'll just refresh this one. So it will be in Parkinson. So that is the reason of mentioning this default index. So let this default index be in 0. So I'll go to this one and refresh this. So it will be in diabetes prediction. Okay. Now, so before going on to building those input fields and prediction models and so on, let's try to add some icons to this. So if you remember the final web page that I've showed you, we have some icons here, right? Now let's see how we can create small icons before this diabetes or disease or Parkinson's. So for that, you can just search bootstrap icons. Okay, so this Streamlit option menu supports this bootstrap icons. So go to that page of bootstrap icons. So just go to Google, search bootstrap icons, and go to the first page, which is icons.getbootstrap.com. Okay, so here you can search for the icons that you need. So you can search relevant icons for this diabetes, disease, and Parkinson's, and so on. So you won't get that much icons, but you can choose the closely related ones. So I'll search something like health. Okay, so health. Let's put this in. So these are all the stickers that we are getting. And for art, let's see. So we have this activity, right? So this is the icon for activity. So I'll just copy this term activity, and here we can. So after this default index or before it, so we can just So I'll just go here, and I'll mention another parameter as icons. So icons is equal to, again I'm creating a list. So for each of these three pages, diabetes prediction, R disease prediction, and Parkinson's prediction, we are going to specify icons. Okay, so that is the reason. So the first icon that I'm going to create is this activity. So main thing is you have to put that in quotes. Okay, and the next icon I'm going to select from here is art. Okay, so let me just search this art. Let's see. Let's just choose a simple one. So we have this art here, right? So let's put this art symbol for art disease prediction. So I'll copy this and I'll paste it here. Okay, so art. And finally for Parkinson's, just go and search as person. So you can choose any icons that you want. So I'll search as person. So this is the icons that I've used before. So just search the icon, copy the name of that icon, and paste it in this list. Okay. So here we have like three pages, right? So hence I'm like selecting three icons. So if you have four different pages, select four icons. So this is how this works. And after this list, you have to specify a comma. So I'll create some space here so that you can understand what are all the things that we are creating. Okay, so I'll save this one. So first is the title of the sidebar, which is multiple disease prediction system. And then this is the name of each of the individual pages that we are creating. Okay. And then we have this, uh, the third thing that we have is our icons. So icons for each of the page, and finally the default index. Okay, so the index in which the, when we open our page initially, where it should be. So I'll save this and I'll go to my page. So I'll close this one. Let's go to this. So here you can see there are no icons, so there is some bullet points or something like this. So I'll refresh this page, and now you can see, so this is my activity symbol, this is my art, this is symbol, and the person symbol. So this is how you can create icons. So now we are into the main part of this code of getting the input from the user. So input is nothing but in this diabetes prediction, so we are predicting whether a person is diabetic or not using the factors such as pregnancies, glucose level, blood pressure, skin thickness, etc. So we have to create input fields with these terms. Okay, so that is the thing. And I'll go to this diabetes prediction. So this should happen when the person select this diabetes prediction. Okay. So we have this page title thing. So after that, you can mention that. So first thing I'm going to say is pregnancies. Okay. So pregnancies. But I think I have these things like already. So I'll just copy this one so that we don't waste that much time. So I'll explain you what this columns means. But for now, let's just copy these things. So first is pregnancy. Let's paste it here. And the second input is glucose. So the important thing, so this is like very important, so you have to note here is, so this should be in order. So this should be in order in which it is present in our data set. In our data set, it is present as pregnancies, glucose, blood pressure, etc. Okay, in the collab file where we are saving the models, if you come to the bottom of this page, so for column in x is nothing but the we are just converting this uh, you know we are just loading this data frame. So after like dropping the outcome column and so on, so this is our data frame. So from this I am extracting all the column names. Okay, so that is what I have written here. So I have created a simple for loop so that I can print the different column names that I have. So that is the reason for this. And for column in x dot columns, print column. So this part of the this code snippet will tell you the name of the columns that we have, which is pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and so on. So this order should be maintained. So that is like very, very important. Okay. So in this, if you see, we have this pregnancies, glucose. So this order should be maintained. So similarly, in all other collab files, there will be the respective features that we need. So in this case, we have this EH, 6, CP, and so on. So if you wanted to know what these things means, just go to Google, search art disease data set. So let's search this as art disease data set Kaggle. Okay, so here it will be mentioned like what is the so it will be mentioned here like what those specific columns means. Okay, so here we have this age 6, so we know that age of the person, sex is the gender, and CP. So if you don't understand what that CP is, you can go here and see chest pain type is what is referred as CP. So you can go through and understand what these different columns mean. And similarly for Parkinson as well, so you can go to just Google and search Parkinson's data, and you will see the description of these columns. Okay, if you wanted to know about that. And for diabetes also, you can see like this is self-explanatory for diabetes. For other things, you can search the Kaggle data description. So this is a final web app that we have created. I'll just copy these things. I'll explain you what all of these things means. And then we have the skin thickness, right? Skin thickness, insulin, BMI. The next thing is the insulin value. Then we have BMI, right? Here we have BMI, diabetes pedigree function. Copy this one. And finally, we have age of the person. So this is the order for that diabetes data set. So I'm pasting this here. Okay, so I have to copy this entire thing. So diabetes pedigree function value. Okay, so I'll save this with Control plus yes, and now let's run our web app to see what are all the changes that are made. Okay. Hmm. Okay, so let's go here and refresh this page. Yeah, so when you select this diabetes prediction, so you will say, so this is where the user will give the input. Okay, so that is what we have created using this st.text input. So st, we know that we have imported the Streamlit library, and text input is for creating those input fields. Okay, so that is the purpose of it. And Okay, so and then you have this, little things here, right? So we have some strings. So number of pregnancies, glucose level, and so on. So this is nothing but what we want to display above these input fields. Say, for example, the first field, we know that it is pregnancy number, right? So we can say that it is the number of pregnancies. So that's what we have mentioned here. So the second one is glucose level. So this is the string that has to be mentioned on top of the second input field. So we have number of pregnancies, glucose level, blood pressure value, and so on. And these are nothing but, so these should be like single word. So here this is a string, so we have like space in between them. So these are like variables, so we cannot like mention space. So that's why we have the skin thickness, diabetes pedigree function, all those things without any space. So these are nothing but are variables in which we will be storing the value given by the user. Let's say the number of pregnancies the person is giving us 2, so that 2 will be saved in this variable called as pregnancies, and glucose value, which is given by the user, will be saved in this value called as glucose. So once we get all these values, we have to feed all these values to our diabetes model, and it will say whether that person is diabetic or not. So that is the end result that we are interested in. So now let's see how we can do that part. So this one is for prediction. So this one is code for prediction. Okay, yes. So it's code for prediction, and here I'll create. Okay, so yeah, so here we have to create a empty string. So I'll call this empty string as diagnosis. Okay, so let's create an empty string. So in this codes there is no space or nothing. So this is what we call as empty string. So there will be this opening quotes and closing quotes. So in this empty string only we will be saving the end result. So the end result is nothing but it is a statement which says the person is having diabetes or the person doesn't have diabetes. Okay, so that's why we are creating this. And now let's do this prediction. So creating a button for prediction. So once the user give all these values and click a button, it will tell whether the person is diabetic or not. So that is the idea here. So creating a button for prediction. Hmm. Now let's create an if condition. If st, so st, we know that it's Streamlit, and Streamlit we have the function called as button. And let's name this button as diabetes test result. Diabetes test result. So once the user click this button, we will get the result. For getting the result, we have to pass this all these values. So all these feature values to our diabetes model, right? So here you can say if st dot button. So that means, so if st dot button means if this button is clicked, then we have to predict the output, which is, let's name this as diab prediction, which is diabetes prediction is equal to diabetes model. Okay, so this diabetes model is what we have loaded here. Just a second. Yes, so it is the diabetes model that we have loaded here. So I have this diabetes model dot predict. So we know that predict function, when you give the input values, it will give you the output, which is 0 or 1 in this case, where 0 means the person is not diabetic. If the value is 1, that means the person is diabetic. So that is the thing. And in this predict, we have to give in the values. Okay. So pregnancies, glucose, blood pressure, skin thickness. So we have to give all these values. So first in the list goes, okay. So within this predict parenthesis, we have to mention all these values and mention like another, square bracket. So this is very important. Okay. So within this parenthesis, you have to create a list using the square bracket, and within this, you have to create another square bracket pair. So this is where you have to put all these values. So then only the model understand that we are predicting for only one data point or one person. So this is very important. So just create two square brackets and close it with two square brackets, and within this we have to give the values as pregnancies. Okay. So first value is pregnancy, and as I've told you, this order is very important. First is pregnancy, then we have the glucose level, and then we have blood pressure. So just use a comma to separate them. So this is just a list that contain all these values. So it is like there is nothing complicated in it. So we have the skin thickness, and then we have the insulin value, and after insulin we have BMI and diabetes pedigree function. Let me just type in BMI here. BMI, diabetes pedigree function, and age. Okay, so this is the last one. This age. Let's paste it here. Okay, so first we have pregnancies, which is given here: glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and DH. So as I've told you, we are just putting all these values in a list. Okay. So all these are in a list, and all this list should be enclosed in another square bracket. So this is just to tell the model that we are predicting for one data point. So that is the reason. So yeah, this pregnancy is glucose, blood pressure, and all those things and so on. So this is to give all these values to the model, and the model will predict whether the person is diabetic or not. Okay, so that is the reason. And so the end result is you will get either 1 or 0, so just like this, so which we have already worked on. So the end result will be a list that contain one value, so the value will be either 1 or 0. So now we have to check what is this value. So if this value is 1, we have to say the person is diabetic. If the value is 0, we have to say the person is not diabetic. So for this we have to create like another if condition, and this should be within this if condition. So once this button has been pressed, this diabetes test result button has been pressed, so this model will predict the value for all these values, and we will get the final result. So if this diab diagnosis or this diab prediction, okay, so diab prediction is equal to, oh, sorry, so this diab prediction of 0 is equal to 1. In that case we will say that diab diagnosis is equal to the person is diabetic. Okay, so let's change this to the person is, okay, so diabetic. Next is else. That means, okay, so this else should come here. So else we have to say diab diagnosis is equal to the person is not diabetic. Let's put this as not diabetic. Okay, I'll explain you what we are doing in this case. And the end result is we have to say st dot success. This st dot success will give us the diagnosis. Okay, so yeah, I think we are done with this one. So let's try to understand what we are doing. So the flow will be, so the user from this navigation bar or the sidebar will select whether he wanted to predict diabetes or heart disease or Parkinson's. Okay. So once he select this diabetes prediction, so it will open this particular page where the title will be diabetes prediction using ML, and we have this input fields: pregnancies, glucose, blood pressure, skin thickness, and so on. And we are like creating a null string or an empty string as diab diagnosis, and within this diab diagnosis, if you see, we are storing the final output which says whether the person is diabetic or the person is not diabetic. So that is the reason we are creating this empty string. And if so, there will be a button, and the name of this or the text over this button will be diabetes test result. Okay, so if the user click this button, so we are feeding all those values which are given by the user to this diabetes model which we have loaded here. Okay, so once we have loaded this, we are just predicting whether the value is either 0 or 1. So if the value is 1, then we have to say the person is diabetic. Or if the value is 0, so else means if the value is 0, so this 0 means the list. So if you go here, so the final result won't be an integer value as either 1 or 0, so it will be in a list, and that list will contain the value as either 1 or 0. So that is how the model will predict the values. Okay, so if the value is 1, here we have to say, so if the value, so this diab prediction square bracket 0 means the element within that list. So if that value is 1, we have to say the person is diabetic. Else if that's not the case, we have to say the person is not diabetic. And st.success will display this result. So we are just creating this strings, and this st.success is another text bar which will display the results. I'll show you how all these things works. So let's go to this multiple disk spread. I'll just save this with Control plus yes, and I'll go here and refresh the page. Okay. Okay, so we can see, okay, so diab diagnosis is not defined. Okay, so we have some error here. Diab diagnosis is not defined. Let me just click this one and see. Okay, so I just made a spelling mistake here. So it should be diagnosis. So I'll copy this one and paste it here. Okay, so that is the reason. Just press Ctrl plus yes and here refresh the page. Yes, now we don't have any errors. So this is the input field where the user has to give in some values, and after that, once we press this click, this diabetes test result, we will get the result here. So I'll show you how this one works for you for here. So let's go to this data set. So this is the diabetes that data set that we have worked on. So I'll open this and I'll fill in those values. Okay, so I'll select this one. Okay, so this is the diabetes prediction app. So pregnancy value, let's put this as 6, and glucose level is 148, and blood pressure value 72, skin thickness is 35, insulin level. So I'm just checking this for this first data point. Okay, insulin, the value is given as a 0, and BMI value it's 33.6, and diabetes pedigree function is 0.627. Okay, and the age of the person is 50. So in this case, the outcome is 1. So 1 means the person is diabetic. So after this, once we click this diabetes test result button, it should say that that person is diabetic because the actual value is 1, right? Let's see whether our model is predicting correctly. So I'll click this diabetes test result. So the person is diabetic. So it gives me the correct value. Now let's check this for non-diabetic person. That means the outcome or the value should be 0. So let's check for this particular data point. For this, in order to remove this, just refresh this page. So you will get this. And the number of pregnancies. So in the second data point, it's 1, right? So I'll put 1. Glucose level is given as 85. Yeah, so it's 85. And blood pressure value is 66. And skin thickness value is given as 29, and insulin value is again given as 0. BMI value, second data point, to 26.6. Okay, and diabetes pedigree function is 0.351, 0.351, and age of the person is 31. So it should say the outcome is 0, right? So that means it should say the person is not diabetic. So I'll click this diabetes test result, and it says the person is not diabetic. So this is how it works. So the user will give in all these values, and our model will predict whether the person is diabetic or not once this button has been clicked. So this is how this works. Okay, so you can open this navigation bar that we have. So this is what we are going to do for heart disease prediction and Parkinson's prediction as well. So I'll show you quickly on the previous file that we have created so that we don't have to waste any more time typing all these things. So only one change that I wanted to create is, so like we have like a lot of empty spaces here, right? So what I wanted to do here is I want to like have number of pregnancies here and glucose level next to it and blood pressure value next to it. So I will be having three input fields in the same line. So that will be the next change that we will be doing. Okay, so for this we have something called as columns in Streamlit. Okay, so that is what is mentioned in this particular code. I'll explain you how this works. So let's make some space here, and here we have to say, so this is for getting the input data. Okay, so getting the input data from the user. Okay, so here I'm going to create columns for input fields. Columns for input fields. Okay, so here we have to create some variables as column 1, column 2, column 3. Okay, so is equal to st dot columns. So columns is again the function that is there in Streamlit. Okay, so columns of 3. So columns 3. The important thing that you have to note here is the number of variables that you are creating. So here we have created column 1, column 2, column 3. So we have created 3 columns, right? So the number here should be 3. If you are creating 4 columns, so that means if you want like four text fields or input fields near to each other, in that case you have to mention like column 4 as well, and you have to put st dot columns, and in the parenthesis you have to mention 4. Okay, so after that we can say with column 1 I want this pregnancies. Okay, so I'll cut this one and I'll paste it here. And next I want column 2. So with column 2, so if you don't understand this, I'll explain you how all these things come together. So the next one is glucose. So I'll copy this and paste it here. Okay, and then we have column 3. So totally we have three columns, right? So it should be repeated. So with column 3 we have blood. Okay, so we have already completed this glucose, and the next thing is blood pressure value. Okay, so we have this blood pressure value. So once this column 1, 2, 3 has been completed, after that it again should be column 1, 2, and 3, because we haven't created column 4, column 5, column 6, and so on. So it should be column 1 again, and now it should be the skin thickness. So it's the same procedure. And now I would say, so this is just for creating those horizontal input fields. So instead of having these input fields like one after the other, we will have it like side by side. So this is another interesting feature that we have in Streamlit. So with column 2, so I've done this for the skin thickness, and now it's for insulin, right? Insulin with column 2, and again it should be column 3. For column 3 we have the BMI. So let me just put this as, so just give a tab here, and with column 1 again, tab with column 2. Okay, so yeah, that is all. So here we are just creating some columns. So we have created like three columns, and the first column we have pregnancy, second column glucose, third column blood pressure, and then we are repeating it. So the second, and then we have column 1 skin thickness, column 2 insulin, column 3 BMI, and then diabetes pedigree function, age, and so on. Now let's save this. So I'm pressing Control plus yes now, and now let's see what is the change that is being implemented here. No, so this is the previous version that we have. So this is the navigation bar that we have. So I'll refresh this. So this is how it will look like. So this is like more compact, right? So this is why we are creating this columns. So the reason we have three columns here. So this is my first column, this is my second column, this is my third column. So the reason we have here is we have created like three columns here, column 1, 2, and 3, and we have given this st dot column of 3. So that's why. So if you want four columns, so you just have to include, after this column 3, so I will just put column 4, and in this 3, I will just mention 4. So that is what we can do here. So here we need like three columns is enough. That's why we are doing this. So let me just go to this page, refresh this one. Yeah, refresh this. So in this we have this number of pregnancies in the first column, and then there is skin thickness value, right? So the reason is, so we have with column 1, that means in first column we have pregnancies, and if you come here in the first column we have skin thickness, and after that diabetes pedigree function is in the first column. So if you go here, that's why we have these things in the first column, second column, third column. So this is like more compact, right? So in this the user can give in some values to predict whether a person is having diabetes or not. So this is how this works. When we have to do all these things for uh, you know for this art disease model and for Parkinson's model. So I'm not going to type in all those things because it is kind of repetition. So it is like almost the same thing. So I'm just going here and I'm going to just copy all these codes. Okay, so I'll just copy from this itself. Okay, so multiple disease prediction. So I'll copy all those things, So it's just a repetition. So as we have done for diabetes, we have to do this for heart disease and Parkinson's as well. So that is the change. So I'll replace all these things so that we don't have to do all these things again. Okay. Yes. Now let's see how all those things come together. So it is like the same codes that we have built before. So just I've completed for this art disease as well. So the only change that you will see here is for art disease we have different columns name. Okay, so age, sex, chest pain types. As I've told you, if you wanted to know what how I'm determining chest pain types, resting blood sugar, and so on, you just have to go to that Kaggle site in order to see the description. And we have the order in which we have to give the features. So age, sex, CP. So CP stands for chest pain, and then we have this TREST So here if you want to see, so that one is for resting blood pressure. So as I've told you, you can go to this and search for heart disease dataset Kaggle, and here you will see the description of all the columns. Okay, so let this load. So you will see the column name. So similarly, you can find what those specific column means for Parkinson's as well. So it is like that simple. Okay. So the idea here is once the user select this diabetes prediction menu, so I'll just collapse this one. Okay. So let's try to understand the flow once more. So first we are like loading this models that we have saved before, and then we are creating this navigation bar where we have diabetes prediction, heart disease prediction, and Parkinson's prediction. So these are just icons and the default index that we have. So now if the user selects this diabetes prediction, so here if they click that diabetes prediction, so if I go here, if they click this diabetes prediction, this part of the code will be executed. So if they click art disease prediction, so if this art disease prediction has been clicked, so this code will be running. Okay, so we have this st.title as art disease prediction using ML, and here also we have like three columns, and the features are age, sex, chest pain types, and so on. Okay, so I'll close this one. Okay, so now if the user selects Parkinson's, and this will be running. So these are all the columns that we have. You can also refer this collab file, which I will be sharing with you. So these are all the column order that we have, and you can also see the Kaggle for those descriptions. I haven't given any description here. So here we are creating 5 columns as we have like several features in this case. Okay, so in this case, if the user selects Parkinson, so this part of the code will be running. Okay, so you can just collapse this here, or you can expand this here, so if you want. So it is like another feature that we have in Spider, so I'll expand this. So it all the things are like the almost the same. So the only difference is, so instead of the diab diagnosis we are creating this R diagnosis, and the name of the button is R disease test result, and here the features change: age, sex, CP, so whatever the features that is present here. So similarly for Parkinson's, so this is the Parkinson's model that we have saved, and so on, and finally it should give us the result. Now I'll just press this Control plus yes, and now I'll go to this uh, local host that we have created here, and I'll refresh this. Now let's see how our entire app come together. Okay. So this is the diabetes prediction. So you can give in some pregnancy number value, glucose level value, insulin value, and so on. So after that, if you click this diabetes test result, it will give you the result. If you go to this heart disease prediction, you have different features here. Okay, so age, sex, chest pain types. So here also we have like 3 columns. Okay, so after giving all those values, just go to this heart disease test result. The values you can refer here. So I will also share this dataset files with you as well. So I'll put all those collab files, all these dataset files, and these model files in a single folder, and I'll share you the drive link from which you can download it and you can run it for yourself. But I prefer you to write your own code so that you will get a better understanding of it. Okay, so we have this diabetes, art, and Parkinson. So you can go to this art, and you can just give in all those values. Okay, so we have this diabetes data, and then we have this R data. Okay, so this is the target. So apart from this target, you can give all these values. Okay, because like target is the final output to predict whether a person is having heart disease or not. So apart from this, you have to give the age, sex, CP, and all those things. If one means that it will be predicted that that person is having heart disease. If zero, if you scroll down, you will find the values, the target values as zero. This means like these person people doesn't have heart disease. So you can just look at those values and type in here for heart disease, and for Parkinson's prediction as well. You can check this particular data set. So this Parkinson's dataset which contain like all those values, and make sure you are like giving correct values. So just look at this column name and fill in the corresponding values that we have here. So here we have like 5 columns as I've told you. So that's why we have like this one here. So after giving on all the values, you can like click this Parkinson's test result in order to predict this. So this is how you can create a multiple disease prediction system, which is basically a multiple page web app, okay, where you can navigate to one or the other. So I'll close this one and I'll show you again how you can open this fresh. So I'll close this one also, which is already running. So here in this notepad file, so this is the path of this Python file in my system. Okay, so you have to replace this with where the path or where your Python file is situated in your system. So this is the main change that you have to do. Okay, so first thing is you have to change the location here or path of the file here depending on where you have pasted or where you have this Python file. And after that, you have to copy this entire thing and go to this Anaconda, open your terminal, and main thing is you have to install all the libraries, Pickle, Streamlit, and Streamlit option menu. So I'll paste this. So it will be Streamlit run double quotes and the path of the Python file that we have worked on. So press enter and this will open your default browser and you will have your web app ready. So now this is not a public app. So this is running in my local host. Okay. In the next video, I'll show you how you can put all these things in your GitHub repository and how you can deploy this as a public app where you will get a URL, and if you can share that URL with anyone and they can access this app and they can kind of see what you have built. So this will be like very useful for you to demonstrate your project in some interviews and things like that. So instead of showing them the code that you have worked on, so you can put this in GitHub and create this public web app, and you can share that URL with the interviewers where they can just see how you have built your app and so on. So I'll show you in the next video on how you can do that as a public app. And before that, so the other thing that I wanted to mention here is, so you have to change the path of the saved files as well. I hope you know this. So this is the path of the saved file in my system. So it is C user Siddharthan desktop and so on. So here I have this saved file, right? So you will be saving this models in a different folder. So you have to replace this path of this with where you have stored the models. So the diabetes model, R disease model, and Parkinson's model. Okay. So these are the two things that you need to do. So one is change the path of this Python file depending on where you are storing it, and within this code you have to change the path of the models where you have stored. So these are all the two things that you need to do. Apart from this, the all the coding part are the same. Okay, so I know that this video is a bit large and it is like a bit hard to understand probably because of the number of things that we have done. So if you have any doubts, please mention in the comments. I'll try my best in order to clarify your doubts depending on how my time is looking. Okay, so that's it from my side. So please watch the next video as well where I'll be explaining you on how to deploy this as a public web app, which will be like really useful for you. And I'll give the link for all those collab files and this Python file and the models, etc. And as well as I'll give the link for the playlist that I've shown before, which you have to refer in order to, before watching this video. So that will be helpful for you. So where you can just click and check for different diseases. So I hope that this video is really helpful for you and hope you have learned a lot from this. Please practice this codes by yourself. So instead of running the file that I'm giving you, please write this code by yourself line by line so that you get a better understanding. And if you have any doubts, reach out to me. I'll try my best to respond to you. Okay, so that's it from my side, and I'll see you in the next upload. Thanks for watching.